All right. This equivalent system's a pretty tough lesson. So let's get down to it. We have two systems of equations are said to be equivalent when they have the same solutions. If they have the same solutions, then those systems are equivalent. Graphically, that means they will have the same points of intersection, whether that's a single point or all the points or no points. We can just create an equivalent system by applying the algebraic properties of equivalence. One way to do this is by replacing one equation with the sum, adding, or difference, subtracting, of the original two equations. So let's look at this example 1 here. If we add these two together, we'll get 17x minus 3y plus a negative 10y is negative 7y, and 7 plus 5 is 12. So that's a new equation that I've created by adding those two equations together. Now I can take that in combination with either of the two original equations, and I'm going to use 2x plus 3y equals 7. So this new system is equivalent to the original system. Now I can make another new system here by subtracting the first from the second, or the second from the first, 2x minus 15x is negative 13x. 3y minus a negative 10y, that's 3y plus 10y, or 13y. And 7 minus 5 is 2. Now again, I can put that in combination with either of the first two original equations, and I chose the second one there. So now what I've created is I've actually created a 4. This says 3, but I actually have created, it's 3. 4. 4 new 3. Geez, I'm going back and forth. So we have the same system was originally created, and each of these two new systems are equivalent to the original. So they're equivalent to each other as well. We can, sorry about that. We can also multiply or divide one equation in a system by a number to create an equivalent system. So in this one, I'm going to take the first equation here, and I'm going to multiply it by 4. Why 4? I don't know, no reason. In fact, it doesn't benefit us in any way here. So when we do that, though, we have 8x plus 12y is equal to 28. And if I take that in combination with the second equation here, this is a new system that is equivalent to that one and equivalent to the first two from example 1 as well. All right. So we can also combine those two methods by multiplying or dividing one equation and then adding or subtracting the two. So I notice that I multiplied this one right here. And again, we're working with the same original system here. So this is the result of multiplying. So I'm going to take that. 8x plus 12y equals 28. So the way we did that was we multiplied by 4. And I'm going to take the the second equation there, 15x minus 10y equals 5. And now I can add or subtract those two, and I'm just going to add. And we'll get, let's see, 23x. That's 8x plus 15x is 23x. 12y plus a negative 10y is plus 2y. And 28 plus 5 is 33. All right, so now we have this new equation there, the 23x plus 2y equals 33. And I can combine that with either of the original first two And we can do, let's do 2x plus 3y equals 7. So I used the first equation there. And so what we say is that this is still equivalent to the original, and so all of the other ones that we've created as well. So let's suppose that you're given two systems and you need to show that they're equivalent. One way is to solve both of them and show that they have the same solutions. Again, we can always show that they have the same solutions, and that means they're equivalent. But that takes a while to solve two systems. There's a faster, easier method, sometimes easier, to determine whether you can use the algebraic properties of equivalence to derive one system from the other. And this is example 4. So we need to prove that those two systems are equivalent. Now, what I notice is that this first equation is the same as the first equation there. And I also notice that here we do not have an x term, I should say. So what are we going to do? We need to get rid of the x term. Well, one thing I think we might do to get rid of the x term is to multiply this equation by 2, and we'll get 4x plus 6y equals 10. And so I'm going to take the original equation there, 4x minus y equals negative 11. And now I'm going to subtract these. That will get rid of my x term. And that will give me, so I have a 4x subtract x, that's 0 x's. Negative x subtract 6y, that's going to be a negative 7, let's use black there, negative 7y. And then negative 11 minus 10, that's going to be negative 21. And so what we've done is we have found a way to derive this second equation by multiplying the second equation from the first system by 2, and then subtracting that new equation from the original first equation, and we've derived it. So these are equivalent systems because we've used the properties of equivalence. All right, I hope that's helpful.